Hello and welcome to the last video of this section. Here we'll be looking to model real-life scenarios with vectors and trigonometry. Okay, so let's read this first example. A girl is walking 2 kilometers due to east and, uh, well, with regard to the position point O and then 3 kilometers south from A. So to picture it on the diagram, we'll we'll have to draw a picture and we are to look for the total distance traveled and the position vector of B relative to O. Part C is just to figure out the magnitude of OB, and part D is bearing of B from O. Alright, so this question involves finding bearings. Bearings are used with regard to positions and on maps. Okay, so let's picture where is O. Imagine that's the origin that we started with, and we took due to east means pointing to east. East is to the right, okay? And we call that point A, and we go south from A 3 kilometers to get to point B. Then this OB here, first of all, the total distance traveled. It's a primary school question. 2 plus 3 makes 5. So total distance traveled part A is rather simple. Position vector of B relative to O. Alright, so let's just get part A out of the way. We put that 5 kilometers there, and notice that arrow pointing up to the north there, because that's where you need to measure your angles from the north line. When they talk about bearing, the bearings are measured from the north line clockwise. All right. If you haven't heard the bearing before, bearing is measured from of that point, north line of any point you're measuring from clockwise, in clockwise direction. So where it says last bearing of B from O, it means that figure out what's this angle here. So we know there's a right angle there because east is directly to the right angle to north line. That's why we put the right angle there. And once we figured out this angle theta, we add it to 90 degree, and that's the answer to last part there. But before we get to the bearing there, we're just going to look out for position vector of B relative to O. That's not hard to see. It's 2 units to the right and 3 units down. So that's 3I and minus 3J. So we're just putting a kilometer as units there because we measure in kilometer. So part B is done as well. Part C is to figure out the magnitude of OBE. That involves using Pythagoras, and we know that because they are perpendicular to each other. So there we go. The answer is 3.61 kilometers. That's the magnitude of OB. Now getting to the bearing. As I said again, measured bearing is measured from the north line, and we need to basically figure out this angle theta and then add 90 degree to it. So opposite side is 3 and adjacent side is 2. You're going to use a tan, and the angle means take inverse tan of that ratio there. 56 degrees is down here, and don't forget to add the 90 degree to it, because after all, bearings are measured from the north line. I can't stress enough times. So there you go. Bearings need to have 3 digits, so you need to round this up or down. If we round it just to 3 decimal places, or rather 3 significant figures. Alright, so in this next question, we've been told that in an orienting exercise, a cadet leaves the starting point O and walks 15 kilometers on a bearing of 120, that means degrees, and reaches point A. And this is the first checkpoint, from A, he walks 9 kilometers on a bearing of 240 degrees and to the second checkpoint B. Therefore, from B he returns back to O. Find the position vector A relative to O, magnitude of OB, bearing of B from O, and position vector of B relative to O. Alright, so let's just put those info on a diagram. You draw north line and bearing of 120 degree means this angle is clockwise, alright, measured clockwise. So we're gonna put A there and put 15 as the distance traveled there. And measuring, what angle we are measuring? 240 degrees. So using your knowledge of 4 quadrants, this angle makes 180 degrees. So this is the north line. From A, alright, so this is we measuring, this origin is A, so we measuring from north line of A, and 102, this the best is 270. You might want to remember that. So that's why 240 is going to be in the third quadrant here. Alright, so that's why we're gonna put a point and draw a line like so. This is just not some random direction here. It has to, if you try to, when you making bearing diagrams, try to make it as accurate as possible. Don't put a line down here, because that's not gonna help you. So you have to point in the right quadrant at least. It doesn't have to be 100% accurate, but it's in the relative to A. This is the third quadrant. 1, 2, and 3. It's pointing in the third quadrant. So then what we put the 9 kilometer there, and then we are saying what's the position vector A relative to O. So what we want to know really is that really we don't know how how far did we go to the east and how far did we go south. We need to figure this east and the distance, the components of this vector really. So we know if we have a direct pointing directly to east, this is 90 degree, and how far more did we turn? We got 30 degrees here. Therefore, I'm going to draw this right angle triangle. There is going to be right angle triangle here, which we need to know its components to answer part A. So we're going to draw that right angle triangle here, and using the fact that the hypotenuse of this triangle is 15, we said that um, the x direction is 15 times cos 30, and the y direction is 15 times sine 30, because we've got angle of 90 degree there and 30 here. Okay, it's just it didn't fit into that tiny slot there. All right, so then we just multiplying and replacing those values with actual numbers, and we're going to use these values as a vector. So 13 comes first, 13i, negative 7.5j. Then we are to figure out the magnitude of OB. Now O is here and B is down there. So how do we find this magnitude here? Maybe we can do some trigonometry here. If we know the angle between OAB, then we will have trigonometry to help us out to figure out this length opposite angle A. So what's that angle? Well, if you think about this, what we just figured out in that right angle triangle is 30 is there, 90 is here, therefore this angle is 60. So what's left is, let me find a different color for you. So this purple angle here is basically 360 minus 240 and minus 60, because those are on the outside of the purple angle there. So once this is adding up to 300, so what's 360 minus 300 is 60. So now we know this angle OAB is 60. Okay, this is OAB. So my diagram is getting a bit messy, so let's just clear everything up. So uh, here we figured out that there's a 60 between 15 kilometer and 9k. Now all we have to do is put the values into trigonometry. Which rule should we use? Now when you have two sides and the angle embracing them, sine. This is where you say SAS means use cosine. Now when I taught you trigonometry, another way is to say, do I have opposite side and to the angle? No, I cannot use the sine rule, so the only rule is cosine rule. So this, this is just saying use cosine rule. So we're going to put those values into the rule here and rearrange it one way or another. You find that's 13.1. So what we did is we just figured out part B. Magnitude of OV is 13.1. So bearing of B from O. So bearing of B from O. So that means that figuring out this angle here, because the bearing involves actually giving this total angle. We know on the top side we have 120, that double line there. 120 is on the top. So if we figure out with trigonometry what this angle is, A, then we need to add it and that will give us the bearing. So let's figure this theta out. This theta means that we actually have the three sides of this triangle OAB, and we can figure theta out. Oh, actually, how do we do that? There is the quickest way is to use the sine rule, because you know 60 is opposite 13.1 and 9 is opposite theta. You use sine rule there and you get the angle theta to be, well, that's just before we take inverse sine here. So theta is 36.6. So I'll put letter O there. It's actually theta. So now bearing, we said that, don't forget this 36.6 plus the 120 above it, because bearings are measured from the north line and given in three significant figures. So you actually round this 36 to 37 and add 120 to it, and you get this answer there. So we've answered part C here, and finally reading part D, the position vector B from O. Now, once again, you have to get your right angle triangle, and we know the vector length OB is 13.1. Using OB as the hypotenuse of a right angle triangle there. So basically, you want to figure out this I and J down here in this right angle triangle. Now it wouldn't be wrong if you drew the right angle like so. It's x and y is the same as x and y of this triangle here, so doesn't matter. So you just take in opposite of, because we know this angle is 36, then what we figured out here is that 180 minus 120 minus 36.6 is 24.4. That's how this came about here, this angle here. Now you can just use it and say sine 24.4 times by 13.1 will give me this length here, and so on and so forth. So let me get rid of that, and finally cos times the hypotenuse will give us the adjacent side. Now position vector means that you give the values in x direction first and then y direction. So what goes in x direction is this number here. So putting that, evaluate that on your calculator, put that in front of I, and put this in front of j, notice that this needs to get a minus sign in front of it, because we know that from our diagram we are going down in a negative direction. So we need to actually have negative 12.1 in for units of j. Alright, so this was the last example, I believe. Yeah. And okay, I hope you found this chapter interesting, and I look forward to seeing you in the next chapter. See you later.